Welcome to Kids Academy.
Ramps are everywhere, and they help us with everyday things. They can help you get up into a place. They can help you get down or out of a place. They can help you get up a staircase easier. They can help you move heavy objects or move heavy machinery. They can also help you get into your home. Ramps can also be used for fun. And if we're talking fun, there's no place where the ramp is king like a skate park.
We're here at Chatham Skate Park for a skate lab. Now we know the #1 rule when we step into the lab, safety first. Today we're going to be talking about force and motion. Now motion is when things move. Force is when you're either pushing or pulling an object. Now what I'm going to do right now is I'm going to try and pull this big crate of bocce balls, big heavy balls, and try and lift them straight up. Let's see how that goes. Oh. Now this is a big heavy crate. You can see it's taking a lot of effort and a lot of work for me to get it up here. Too much. There's got to be a better way. I have here a ramp. Now this ramp can still get me from the ground to the top, but just at a different angle. But I'm going to use science and my brain to make it easier. Now I barely even need to pull, and I can get the crate all the way to the top. We got a bit of an experiment set up. We have a basketball. We have a 15-pound kettlebell. And we have a whole box full of bocce balls. So what we're gonna do is we're gonna put each one of these objects into our skateboard crate of science, and we're gonna roll it down this ramp. Then we're going to find out how far it goes, and we're going to mark the distance with each piece of chalk. So first, we'll test the skateboard with just the crate and nothing inside it. Then we'll test it with the basketball. Then test it with our 15-pound weight, and then test it with our bocce balls. Which item, or the empty skateboard, do you think is going to travel the farthest after rolling down a ramp? First up is our empty crate. You can see there's a rope in there. The rope is actually tying the crate down so that we don't lose it. I made 2 lines here so I can see where the wheels go to each time, so that each object is released from the same distance. Now let's load up our basketball and see how far this takes us. I want to pull it back to the same place, have my skateboard aiming the same direction. Basketball is in, and let's send it on. Now the basketball, not weighing very much, almost made it to our empty, but came up just a little bit short. Now we're going to load up our 15-pound weight. Now this is significantly heavier than the basketball. Do you think it'll go farther or not as far as our basketball and our empty crate? And let's send it on. Past the basketball, past the empty crate. There's the basketball, the empty crate, and our 15-pound weight has made it all the way here. Let's make a mark there. We're at the drop line. Now, how far do you think this one's gonna go? Let's send it off. Last one traveled significantly farther. There's the basketball, there's the empty crate, there's the 15 pounds, and our bocce ball made it all the way down here.
It seems the heavier the object on the skateboard, the farther it traveled.
Now let's try launching our skateboard from different heights on our ramp. We have launch number 1, where the back wheels will be at this line. We have launch number 2, where we'll pull the back wheels all the way up to here. And then we have launch 3, where we're going to put the back wheels all the way up here. Which one of these do you think is going to make the skateboard go the farthest? Here's launch number 1. Launch number 2. And launch number 3.
When I let the skateboard go from down low, it didn't travel very far. The second one a little bit farther, and the third one all the way up the far ramp. The higher on the ramp I released the object, the farther it went.
Now, that's a lot of fun science, but let's use these ramps for what they were meant for. Whee!